Okay, today we are going to do derivatives of inverse trig functions. And before we do that, we're going to have to review inverse trig. And really review trig. So we're going to do that. And I want you to try to do the class openers right now. Okay, you guys, what's the first one? This is the cosine times 6x. Now, on this one, let's pull that 2 and put it out here. So the derivative is, first you do the derivative of the squared. So it's the tangent of 9x, then times the derivative of tangent, which is secant squared. If you want to do this, you may. Doesn't matter. Not 1. Derivative of 9x is 9. Okay. You have to memorize. No, we gotta do this. You can do the one on the outside inside sheet. There are a couple problems on here that we haven't done. Okay, you guys. Okay. Ready? Like this is not. Okay. Now, we're going to do, you guys, we're going to review inverse trig. What is inverse trig? Guys in the back, what is inverse trig? When you see an inverse there, it's the what? It's the angle. So this means, well, it really doesn't. I'm going to use this trig equation to help me find the value of the inverse trig function. The sine of some angle is 1 over the square root of 2. How many numbers make that equation true? More than that. There's a whole bunch of infinite number of angles. Because you can go around the circle more than one time. Okay, I'm going to look at a sine function. So we're going to have to look at restrictions here. These are angles. And we also have to remember some other things here, like what does my triangle look like? So I'm going to add a page, and let's put in my shapes here. I have that one and that one. I added a page. Okay, so we have to know our basic trig. And let's do this one first because that's easier. Now, if this is a right triangle with the legs congruent, what kind of angle is this? It's 45. Do you know what that is in radians? Pi over 4. You're going to have to be in radians on the exam. So this is, now I don't like fractions, so this is 1, this is 1, and then what's the hypotenuse? Square root of 2. And my question was, I want the sine of what angle is 1 over the square root of 2? Now, do you remember what sine is? SOHCAHTOA is opposite? Right. It's 45 degrees or pi over 4. No, it's not bad at all. Except, you may use degrees, but if it's multiple choice, it'll be in radians. That means the sine of what angle is 1 over the square root of 2. Okay. Yeah. That's 45 degrees. So how do you change it? You take 45 degrees times, and then it's pi over 180 degrees. That's how to convert to radians. Okay, Noah? Yes. Let me fix. Okay. Now, the problem with the inverse trig, let's look at the sine function and what it looks like. And so we're kind of reviewing everything kind of quickly here. But still might. Or is it you guys? Okay. Now, you remember what the sine function looks like, right? It looks like this. Now, if I want to find its inverse, reflect over y equals x, and is that a function? This is the inverse. Doesn't pass the horizontal line test. The inverse of the sine function is not a function. So what we do, okay, guys, is we restrict the domain so that we will get an inverse that's a function. So we're just only going to look at where my function's increasing. I could take this interval here, or I could take this interval here. There are a lot of different intervals. I'm going to take the first one because everybody else has decided to do that. So what are my angles between? Remember, these are angles here. Theta is going to be between pi over 2 and negative pi over 2. So if you were to type this into your calculator will always give you an angle between negative 90 and positive 90. Now, that is different than saying that the sine of theta is equal to 1 over the square root of 2, because how many values make that sentence true? Infinite. So I use this to help me figure out what the angle would be. But I must always just restrict myself to be between pi over 2 and minus pi over 2 for the sine function. And it's actually going to be easy to remember. So what about the cosine function? How are we going to restrict that one? But let me back up a little bit. You know, we do this with the parabolas, because what if I take a parabola? It looks like this, right? What would its inverse look like? It would look like this. Is that a function? No. So we restrict our domain on our parabola so that our inputs are always positive. And then when I come over here to my inverse, I do have a function. And so we've chosen to do that. Well, I'm doing exactly the same thing with the trig. I'm just going to choose that I'm only going to look at a small piece of this graph right in here. You can barely see that. So let's look at the cosine. And generally speaking, what I want is my function to always be increasing or always decreasing. Okay, so we're going to graph the cosine function, which looks like this. And I want my cosine to always be increasing or always decreasing. And the problem is if I take this here, what's happened here? It's increasing here, but then it's what? Decreasing. And it doesn't pass the horizontal line test. So instead, I will take this part right here and just have it always decreasing. There are other intervals I could take. I choose that one. So what's my angle going to be between 0 and pi? Cosine is the only one that's kind of strange that does that. Now, so on your calculator, the angles that you get out when you do your inverse trig will be between 0 and pi. Yes, we've all agreed to that. We could have done between pi and 2 pi. So this is valid. But somebody decided this a long time ago, so it is what it is. Well, what about the tangent function? There are restrictions on that as well. Whoops. But we can remember this easily. So here's the tangent function. And do you know where these asymptotes are? Pi over 2 and negative pi over 2. Try not great. So my angle for the tangent function, when we restrict this one, will be between pi over 2 and minus pi over 2. That's right. So inverse tangent is the same as this inverse sine. The only one you have to remember that's different is the cosine. That's it. So that makes that easy if you think about it. Isn't inverse tangent what? Tangent is sine over cosine. You don't want to break into sine and cosine. Leave it as tangent. Okay. Now, we're not done with our triangles either. This is the 45, 45. Let's do the other triangle. Now, I don't like fractions, so I'm going to make this side 2 rather than 1. And you guys remember, if you drop the perpendicular, it bisects this side, and it bisects the angle. Did you know that? Do you remember that from geometry? So that this side is 1. This is 60, so this is 30. There's your 30, 60, 90. So when you go into the exam, I highly recommend that you draw the 30, 60, 90, and the 45, 45, 90. And I just showed you how you can do it if you forget. Because I want to take your stress down. Now, we can find this side pretty easily by Pythagorean theorem, which we're going to use a lot of today. So that's the square root of what? 3. You got to subtract them. Okay. Now that I have that, I will put this on my paper in the beginning of the exam and refer back to it as needed. And then I don't have to think about it. I don't have to go, oh, what's the sine of 30 degrees again? Because then when you get panicky and then you mess up. Okay. So I don't like to see inverse cosine. That really means the cosine of what angle is equal to the square root of 3 over 2. So now I'm going to look at my triangle. Ready? And I want the square root of 3 over 2. So cosine, remember, is adjacent. So it's this one over this one. So how many degrees is that? 30. And what's 30 degrees in radians? Pi over 6. And I can remember that because I want 30 degrees to be pi over 3, because then life would be really easy for memorizing. But I know it's wrong. So I know that this is pi over 6. That's how my head works. Now, is pi over 6 between 0 and pi? Yeah. Okay. How do we use what? Are you ready? The inverse is an angle. So when I look at this, I'm looking for an angle. This is not calculus yet. This is just pre-calc. It's the inverse trig, which we're not real happy about. So I don't like to look at inverse trig, just like I don't like to look at logarithms. So this is my angle, theta. It means the tangent of what angle is equal to the square root of 3 over 1. Now it's got a square root of 3. It's either going to be 30 degrees or 60. I'm looking for an angle such that the tangent is the square root of 3 over 1. So I'm going to go back to my picture. Tangent, is the square root of 3 over 1. Opposite over adjacent. So it's 60 degrees, which is pi over 3. Okay, life is good. We're in the first quadrant. Life is not good on the next one. Well, let's draw the picture. Now, remember, for the inverse sine and inverse tangent, I'm going to be between minus pi over 2 and pi over 2. So it's this. And to get these angles, it's a negative angle. Well, this is what? If this is theta, let's first do the positive one. Tangent of theta is equal, this is my reference angle, is going to be square root of 3 over 1. Well, we already did that. What's this angle? This is pi over what? Look at C. It's the same question without the negative. It's pi over 3. So how do you get this angle? It's negative pi over 3. Remember, inverse tangent, my angles will be between pi over 2 and negative pi over 2. So you have to go backwards into the fourth quadrant. If I go around this way, I don't get a negative number. That's whatever it is. I don't want to count it. So this is going to be negative pi over 3. So when you get the negative sign in here for sine and tangent, it's just a negative angle. Cosine, you got to do a lot more work. You got to figure out what it is. Only one answer. The cosine will be in the first two quadrants. Cosine will be here. So you find your reference angle, and then you have to find this angle. Sine and tangent, if it's a negative number, make it a negative angle. That's how I just make it simple. Cosine's the only one that's tricky. Okay? So what happens if I take an inverse cosine of a cosine? Right here. These are opposite operations. What are they going to do to each other? Cancel each other out, and you get what? 0.6. Can't you see the point? I can see the point. Okay, are we ready? Now, this next identity is a little tricky. Okay, you guys ready? There's a lot of stuff here, by the way. Yeah, let's leave it. Now, I know what you guys want to do, Jack. You want to say inverse, nice. You want to say that the inverse secant is 1 over the inverse cosine. It's not. It's not. I want to say that as well, but it's not. So if I have this, there's a variety of ways you can work through this. So remember, an inverse trig function is an angle. So that means the secant, the secant of my angle is equal to x. Now, can I write x as a fraction? I'm going to start doing this because you're going to see what. It's x over 1. So if I look at my picture, I'm going to draw a triangle. Here's theta. Now, if the secant is x over 1, Jack, where do I put the x? It's secant. Where's the hypotenuse, the 1 or the x? Remember, secant. Secant is the hypotenuse over the adjacent. So this is the x, and this is the 1. Can you find the other side? Always. Pythagorean's theorem. So it's going to be, do I need to do the work, or can you tell me what it is? We'll call it h. So 1 squared plus h squared equals x squared. Solving for h squared equals x squared minus 1. So what's h equal to? Square root of x squared minus 1. Can I make that x minus 1? No. Cannot distribute exponents, which is what a root is. Okay. Now, if the secant is x over 1, what's the cosine of theta? It's 1 over x. If I solve this second equation for theta, that's equal to inverse cosine of 1 over x. Do you agree? I'm going to solve for theta. I could take inverse cosine of both sides as an operator. Solving for theta, it's the inverse cosine of this, 1 over x, just like logarithms and exponentials. But I already know that theta is equal to the inverse secant. Now, did the angle change in this? Did the angle change? No. So if the thetas are the same, what has to be true about this side? Those have to be the same. So that I get the inverse secant of x is not the reciprocal of the cosine, but it's the inverse cosine of the reciprocal of the x. Now, I don't bother myself with remembering this. I just do the problem because it's easier. I started off with inverse secant of x, call that theta, so I rewrote it, secant of theta is equal to x. So then I drew a little picture over there. And I said, what's the cosine then of my angle? If the secant is x over 1, and the cosine's 1 over x. Then I solve for my angle here. If you want to think of it as taking the inverse cosine of both sides, what happens to these guys? They cancel. And I'm left with theta equal to the inverse cosine of 1 over x. Well, I already know theta is equal to the inverse secant. So what has to be true with the inverse cosine of 1 over x and the inverse secant of x? They have to be the same. I'm not reciprocaling the trig function. I'm reciprocaling this number. I'm just showing you that you, I will use it down here. Pardon? I'm just showing you that inverse secant is not equal to 1 over the inverse cosine of x. I know you want to make it that way, but it isn't. The inverse secant is not the reciprocal of the inverse cosine. What are you going to reciprocal? You're going to reciprocal this little thing in between here. This, x. That's what gets reciprocaled. But would you think that? It doesn't feel natural to me. This is it. That's the relationship. So, I mean, you can learn it if you want. I would just figure this out. If the inverse secant of 2 is theta, that means secant of theta is 2 over 1. Draw my little triangle. Here's theta. Where's the 2 go? Yep. And it was secant, so this is 1. So, what's my angle? No, I want the angle. Okay, that's 60 degrees because this is the 30. So it's pi over 3. It's the 60-degree angle. Don't mess me up. Okay. Okay, do you remember your inverse trig a little bit? There are probably some problems in the book. There was a handout, but I don't have it. I'll give it to you tomorrow when I get it. I don't know why I don't have it. Okay. Now, these are some trig identities, you guys. I'm going to work through them. I don't memorize them. I'm going to need them when I do derivatives. So this is just a little practice. This is my angle. Inverse cosine of x is equal to theta, which means what? The cosine of theta is equal to x over what? 1. I haven't done the sign yet. Just started with the black part. Okay, guys? Put your iPhones away and your music away. We're doing this right now. It's a lot easier if you pay attention. I can go twice as fast. So if you have enough time to play with your phone, it means I'm going too slow. No, I don't want to. Okay. No, because then you'll have even more time to play with your phones. Cosine of my angle is x over 1. So where does x go? Adjacent over hypotenuse. Does that help? SOHCAHTOA? So this is x, and this is 1. And then I want to find the sine of that angle. Well, the sine is going to be this side, so I need to find that side. Can we just say what it is? It's Pythagorean's theorem. It's the square root of hypotenuse squared minus length squared. So it's 1 squared minus x squared. So what is the sine of my angle then? The sine of this angle is opposite over hypotenuse. So it's equal to square root of 1 minus x squared. No, I'm doing both. You have to think of this as an angle. That's what the answer is. This is an identity. The sine of this equals this. We're going to do a bunch of these. We got 4 of them. It's an identity. It says I want the sine of this angle. So what is that angle? The cosine of my angle is x over 1. I don't know what the angle is. Okay. Hey, you guys. Focus. You get it, try the next one. But by the time we're done with 4 of them, you should get it. Because I'm going to need it to find my derivatives. Unfortunately. Okay, you ready? Casey, are you ready? This is my angle. The inverse sine is the angle. Well, I don't want to write it that way, just like I don't write a logarithm. I write it as exponentials. So this means, I use this as a tool. The sine of what angle is equal to x? I don't know what the angle is. I have no idea. But here's my theta. Where do you put the x? It doesn't matter. I just always put it there. So this is x, and this is, and what's this side then? 1 minus x squared. So now, Alexi, what is the cosine of my angle? Look at the picture. It is. What's the cosine of this angle? Cosine is the adjacent over the hypotenuse. Yep. Okay. 2 more. So you get practice with this. Okay, we're going to do this one. Turn the page. Maybe you're on the same page. I don't know. Okay, Casey, Colin, how do I do this one? It means the tangent of my angle is equal to x over 1. So here, I can put my angle either place. I'm going to put it here. So the tangent is opposite over adjacent. So this is x and this is 1. What's this side? Square root of x squared plus 1. Is that okay? And then what's the secant? Now the cosine is 1 over the square root. So what's the secant? The square root over 1. Secant is the reciprocal. This is not inverse secant. It's just plain old secant. So it's going to be the hypotenuse over the adjacent. I'm sorry, what? It's not an inverse. Inverse would be different than that. Okay, ready for the last one? Noah, do you know how to do this now? Here's theta. So the secant of my angle, yes? Okay, yeah. This is an angle. So that means that the tangent of my angle is x over 1. The inverse trig means an angle. So when I have inverse secant, that's my angle. Secant of what angle gives me x over 1. So we go to my triangle. Here's my angle. Put it wherever you want. But the secant is the hypotenuse to the adjacent. So what's this side? This is x. This is 1. Can you find the other side? Yes, you can. Pythagorean's theorem. X squared minus 1. It doesn't matter. I just did it here because I'm used to it, but I could do it here. Then these will switch. No big deal. But I haven't done the tangent yet. What's the tangent? Because Pythagorean's theorem. What's the... Okay, you guys. So what's the tangent of my angle? Opposite over adjacent, so this is equal to. Notice I never figured out what the angle was. I don't care. Yeah, it's over 1. Okay, why do this? Okay, guys, Casey, let's find the derivative. These are the two you need to know. Let's find the derivative of inverse sine and inverse tangent. Those are the ones you're going to memorize. But right now, we're going to figure out what they are. Because if you're on the exam, you can always figure it out. Okay, that's it. That's what that is. That's an identity. So what's the derivative of this? You know what? I don't know. Now, I want d theta dt, dx, sorry. So let's rewrite this, because this means what? Means the sine of my angle equals what? X over 1. Now let's find the derivative of that. d dx and d dx. I'm hoping that you're starting to see the chain rule more and more in the implicit differentiation. What's the derivative of the sine of theta? It's cosine of theta times the derivative of the inside function, which is d theta dx, equals, and then I take the d dx of x, which is dx over dx, which is what? 1. So if you solve for the d theta dx, it's equal to 1 over the cosine of my angle. Well, my problem is I don't want the derivative of the inverse sine to have an angle in it. I want it to have x's in it. So let's draw the picture. It says the sine of theta is equal to x. You guys see that? So I'm going to draw my little picture. Here's theta. Sine is x. So it's opposite over hypotenuse. What's this leg going to be? 1 minus x squared, right? So this is equal to 1 over the cosine of my angle. Girls, what's the cosine of my angle? It's adjacent over hypotenuse, so it's the square root of 1 minus x squared over 1. So that's the derivative of the inverse sine. Is that okay? So what about the derivative with the chain rule in it? Lexi, what's that going to give me? It's 1 over the square root of... Now, what's my x? It's not x. What's my input? The f of x. Okay, you guys. Times the derivative of the inside function, which is f prime of x. What about the other one. There's two you need to know. I'll give you the inverse cosine because let's just do that right now. The derivative with respect to x of inverse cosine of x is equal to negative 1 over the square root of 1 minus x squared. That's the difference. It's a cofunction. The derivative of the inverse cosine is the same as the derivative of the inverse sine, but it's a cofunction, so it's negative. All cofunctions are negative. You're probably not going to use that one. Sine, since it's negative. Yep. But what about the inverse tangent? So let's do that one. Yeah, we're going to do that right now. Call this theta. This is theta, which means that the tangent of my angle is equal to x over 1. So if I draw the picture, here's theta, tangent is x, and this is 1. What's the hypotenuse? Square root of 1 plus x squared, or x squared plus 1, doesn't matter. Okay, ready to take the derivative with respect to x? What's the derivative of the tangent function? Secant squared of theta times the derivative of the inside function. So it's d theta d what? X. So it doesn't go away. And what about on the right side? Is 1. If I solve for d theta dx, it's 1 over secant squared of theta. Now, look at your picture. Remember what secant is? Just divide by secant squared. Well, the cosine is 1 over the square root of 1 plus x squared, so secant is the reciprocal. So it's the square root of 1 plus x squared over 1. And so it's 1 over, and when I square that square root, I'm just going to get 1 plus x squared. Because it says it's squared. Yeah, no, I'm not the numerator. But 1 squared is 1. Because it's the secant squared of theta, not the secant squared of the... There's no squared over here. So what's the derivative of the inverse tangent of f of x? Because you're squaring it. Because it's 1 over the square root of 1 plus x squared squared. So what's this? This is 1 over 1 plus the input, which is f of x squared, times the derivative of the inside function. Is what? Because the formula for tangent is 1 over 1 plus x squared. What's my input? It's no longer x. It's now f of x. This is composite functions. Then what do you have to do? Multiply by f prime of x. Tangent, no, you don't want to do that. Do it this way. Yeah. Okay, Casey. Question? That's the answer. Now, on this handout, okay, guys? On this handout, on this little chart, cross out inverse cotangent, inverse secant. You do not need to know those. But the top 3 you need to know. Just cross out the bottom 2 rows. We're not doing those. Mm-mm. Well, you guys tell me, because I don't believe they're on there. Okay, so we got a couple problems for you guys to try. So we're going to skip those. Yay! And now we're going to do these. Now, I wrote them on the board. We don't have to know them. One less thing to memorize. I wrote them on the board. There they are. But this isn't inverse sine of x. It's inverse sine of x squared. So how do we do that? It's 1 over the square root of 1 minus, what's my input? X squared. And what are we going to do with that input? We're going to square it. Chain rule times derivative of the inside is 2x. Your outside function is your inverse, and your inside function is x squared. You multiply them. Doesn't matter. Okay, how about the next one? Alexi, do you know how to do this one? The first b. 1 over the square root of 1 minus, what's the input? 3x minus 1 squared times 3. Sorry it takes forever to come up with this. It doesn't take long to do it. Yeah. Okay. What? Yeah. What about the tangent? I got that on the board too, Casey. Okay, guys, what about the tangent? Alexi, do you know what this is? It's right behind me. We're not. We're just taking this derivative. So it's 1 over 1 plus times. We have to do the derivative of that square root. Okay, what is that? 1 half x plus 1 to the what? Negative 1 half times the derivative of what's in there, which is 1. That's no big deal. The derivative of x. Had this been a 3x, it would have been times 3. Okay, one more problem, you guys. I know, it's a long day. Tomorrow's a lot, well, you do or don't. These are our last derivatives. But what is velocity? It's the derivative of x with respect to time. So guess what you're going to do? Take the derivative. Okay, Matt? Matt. So how do you find dx dt? Well, 1 over 1 plus the x squared. What's that going to give me? T. Times the derivative. Okay, guys in the back? This is t to the 1 half. Okay, let's do it. The square root of t squared, yes. Then the derivative of t to the 1 half, which is 1 half. Pardon it? It's the square root of t squared. So it's 1 over 1 plus t. And this is times 1 over 2 square root of t. And we're going to put in 16. Okay, you guys ready? Jack? I'm just following the rules. It's 1 over 1 plus the input squared. That's 1 over 1 plus t. Times the derivative of the inside function. Well, that's t to the 1 half. So it's 1 half. T then go down by 1 to the negative 1 half. And now we're going to put it at 16. This? What's the square root of t squared? What's t to the negative 1/2? 1 over t to the positive 1/2. Yes, because the negative exponent. So, you guys, at 16, it's 1 over 17. So it's 1 over 17 times 1/2 times 1/4, whatever that is. I don't care. What's t equal to? It's 16. Just substitute 16 in. I don't know. I don't really care. Whew. It is time. Whose paper am I stepping on?